All right, today we're going to do less simple stoichiometry problems, but I'm going to show you how these problems are actually done exactly like the simple stoichiometry problems. The key to remember here, the thing to remember here is, and it's the number one rule that we need to have. You can write this up at the top. If you've got some notes and you want to do this in the notes, that's fine. I left enough room down here for us to be able to write this down, but if you haven't printed this off, of course, that's going to be a little problematic. So what we're going to do is we are going to take this problem and we're going to work this problem out. Now, I believe I've said this before, and I definitely said this in Canvas, that this is the same exact reactions that you had from the prior assignment. So I already know from problem one, this is the reaction here is N2, well, there it goes, N2 plus H2 yields NH3. And we've already spent a long time on how to balance these, so I'm not going to go over the fact that this is a 3 and this one gets a 2. All right. Now, these problems are just like simple stoichiometry problems, except for one thing. We need to remember the cardinal rule, rule number 1 or rule number 0, whichever way you want to. You must be in moles before converting substances. And that is, remember that step where yesterday we were you used the coefficients here, right? All those yesterday were moles to moles. We were already in moles. So to make these problems just like those from yesterday, you've got to remember you have to be in moles before you can convert from one substance to another. It's rule number 0. It's the most important. It's the cardinal rule in doing stoichiometry. It's the number one thing that people mess up. All right. So what we're going to do here is we're going to start off with 10.0 moles of H2. It says hydrogen gas right here, by the way, right? That's where that 10.0 moles of hydrogen gas, the only number in the problem, goes in the start right here. And I know that this thing right here is hydrogen gas. Notice I don't use the coefficient here, right? That 3 came from me balancing it. It's a different thing, but that's where the H2 comes from. So we're going to put that right there. Now, cardinal rule number 1 is you must be in moles before you convert the substance. So this problem already starts off in moles. The next problem does not. So we'll look at that one hopefully in this video, actually, if I can get this one in less than 10 minutes. So when we come out here to the end, it is asking us to calculate the grams of ammonia. So out here at the end, I need grams of ammonia. This thing right out here at the end must be ammonia. NH3 is ammonia. All right, so rule number 1, must be in moles before converting the substance. So I'm already in moles, so I don't have to worry about doing this. I can just put H2 down here at the bottom. And then we're going to go to NH3 because that's what I want. I want NH3 in my final product right there, right? It asked me to find grams of NH3. I've got to get to NH3 before I can find grams of NH3. Excuse me. So in front of H2, there's a 3. In front of NH3, there's a 2. And what cancels out? Gone. Gone. We are left with moles of NH3. We don't need moles of NH3. We need grams of NH3. So we're going to put moles of NH3 down here on the bottom, and we're going to put grams of NH3 up here on the top. Now, to know what goes in there, I have to remember, you can flip back to your notes from last week, where we talked about 1 mole of NH3 is equal to 6.022 times 10 to the 23rd particles of NH3. And it's also equal to something that comes off the periodic table, which is the molar mass, which is in grams. Ran out of room there, so I'm going to put grams underneath there. So how do we find the molar mass of NH3? Well, remember, we have to take nitrogen plus hydrogen times 3. So that's going to be, if we look at the periodic table, nitrogen is 14.01. Hydrogen is 1.01. And times 3 gives me the molar mass, doggone it, that's a 3, that's a 3, it's just a hiccup 3, there we go, is 17.04 grams. All right, so we're going to take that number, we're going to put it in for grams. 17.04 grams versus 1 mole. Now, if you need a reminder of that, go back and look at my molar mass video where we looked at the molar masses of these things, or there's a mole video about that a few videos back. All right, now what cancels out? Well, NH3 gone, gone, and moles gone, gone. The only thing I'm left with is grams of NH3, and that's what I want my answer to be in. So these problems, if you use factor label, are exactly the same. They're always going to be the same. It's just going to be the same steps over and over again. So we do this math, we plug this in. I'm going to let you plug this in. It should be somewhere around 300, I think. Let's see. Oh, no. 10 times 2 over 3 is 6 times 17. Oh, yeah, it's got like 102-ish. That's that problem. The next problem, when we start this one off, it's going to be the lead nitrate. By the way, you don't need to be able to write these. You do need to be able to balance them if I give you one. I forget which one comes first. I think it looks like it says potassium nitrate and lead iodide. So it looks like it's supposed to go in that order. You put a 2 there and you put a 2 there. That's a K, by the way. That's a K. There we go. That thing is balanced now. And so now it says we have 15, right, 15.0 grams of lead nitrate. Draw the line, draw an equal sign. I know this one's already going to be two-step because all these are going to be two-step. It asks me how many moles of lead iodide, PbI2, are we going to get? Well, now I've got to go from grams to moles first because remember that cardinal rule, we've got to be in moles before we can convert from one unit to another. So you got to do the mole thing first. So we need to know how many grams per mole are there for lead nitrate. Now I'm going to be honest with you. I can sit here and I can do this, right? Lead is going to be 207.2 plus open parentheses. Nitrogen is 14.01 plus oxygen 16.00 times 3. Oops. Close parentheses times 2. If I plug that in my calculator, it's going to give me something like 331, I think. But a better way to do this is to ask Google molar mass lead to nitrate, or PB open parentheses NO2, right? It'll excuse me, doggone it, where is my mouse? There we go. All right, so Google tells me right there. And if I'm not sure, if I want to double check, I can go over here and I can look, and it gives me the formula. I'll make sure I got the right formula, right? So this is lead nitrate, and there's the molar mass, 331.2. So that's 331.2 goes in front of grams. What goes in front of moles is a 1. Gone. Gone. That would be, by the way, moles of lead nitrate. And just to prove to you that I don't have to know that that's lead to nitrate, I can do molar mass PB NO3 close parentheses 2, and it gives me the same thing. Okay? So you can double check your work here. Don't be afraid to do that. Moles, now we go from PB NO3 to PbI2. And there's a 1 there, and there's a 1 there. So both of these get a 1. Gone, gone, and I'm left with moles of PbI2. Once I plug this in, I'm going to get my answer. I believe once you round it, you get 0.05, as I remember on this problem. And that's all there is to it. See, it's just using factor label, just in a slightly different way. Just remember, you first need to be looking at moles, right? You have to have everything else canceled out before you can convert your substance, before you use that balanced chemical equation.